Hey all, today we are going to cover the important topic called multi-agent systems. You think AI is powerful today? Let me challenge that. What you've seen so far, chatbots, copilots, assistants, is just one brain working alone. The real revolution is when AI stops being a soloist and becomes a team. Imagine a coder agent writing features, a QA agent testing them instantly, a compliance agent checking regulations, and an ops agent deploying, all collaborating in real time. That's not science fiction, that's multi-agent systems. And if you're an IT professional, engineer, or business leader, this is the concept that will redefine how you build, scale, and lead in the AI era. What is a multi-agent system? A multi-agent system is like a team of specialized digital workers collaborating to solve a complex problem that a single agent or a single large program would find difficult or impossible to handle alone. Now let's talk about agents in multi-agent system. Agents are independent, autonomous entities like small AI programs or robots that can perceive their environment, make their own decisions based on their goals, and take action. Each agent typically has a specialized role or expertise. When it comes to environment, what it does in multi-agent system, the shared space, physical or virtual, where the agents operate, perceive information, and interact with each other. When it comes to interaction, the mechanisms agents use to communicate, coordinate, negotiate, or even compete with one another to achieve their goals. Let me explain a use case here for better understanding. Imagine you have a huge complicated project like planning an entire party. Instead of having one person, a single AI, try to do everything, the cooking, the invitations, the decorations, the budgeting, you hire a team of specialists. The chef agent handles all cooking and food logistics. The designer agent focuses only on decoration and layout. The budget agent manages the spending and tracks costs. The scheduler agent coordinates when everyone needs to deliver their part. The multi-agent system is the combination of these specialized agents working together. They constantly talk to each other. Example, the chef tells the budget agent how much ingredients cost and adjust their plans to achieve the shared overall goal. The core idea is specialization and distributed problem solving, breaking a large complex task into smaller, manageable parts and assigning each to an expert agent. This makes the overall system more robust, flexible, efficient. Let's break down how each functions. Let's understand robust how it works. If one agent fails, the designer agent crashes. The other agents can often continue working. Now let's talk about flexible, how it works. You can easily add, remove, or update specialized agents without having to rebuild the entire system. Last but not the least, let's discuss about efficient, how it works. Agents can work on their specialized tasks simultaneously or parallel. Now let's talk about the four defining traits of agents. Think of a traditional program. It's like a factory machine. It does one job exactly as instructed and stops. An agent, by contrast, is more like a skilled worker. It can perceive what's happening around it, adjust its actions, and even coordinate with others. Now, what makes an agent truly different from a simple program? Let's deep dive into the four defining traits: autonomy, reactivity, proactivity, and social ability. Let's break down each trait. What is autonomy? A true agent doesn't need constant human input. It decides when and how to act. Imagine a financial agent that notices market volatility and autonomously rebalances a portfolio. Let's talk about reactivity. Agents respond to changes in real time. A logistics agent might reroute deliveries instantly when traffic conditions change. Now let's understand what is proactivity. Agents don't just wait for instructions, they anticipate needs. A healthcare agent could proactively schedule follow-up appointments based on patient data trends. Finally, let's understand what is social ability. Agents communicate with other agents or humans using structured protocols. This is where MS shines. Agents don't work in isolation, they form networks of collaboration. Together, these traits transform agents into dynamic participants in a multi-agent ecosystem. And when you combine dozens or hundreds of agents, you get emergent intelligence, complex outcomes arising from simple interactions. Just like ants in a colony or bees in a hive, mass achieves more than the sum of its parts. This slide highlights how agents work together. Let's discuss in detail. Agents in a multi-agent system work together by using communication to share information, coordination to manage tasks, and distributed decision-making to collectively achieve goals. Their success hinges on each agent having a clear role and specialization. 1. Roles and specialization. In en masse, the overall problem is decomposed into smaller tasks, and specialized agents are assigned to handle them. This division of labor makes the system more efficient and robust. In role, the general function an agent performs within the system, example, supplier, the scheduler, sensor. In specialization, the specific capability or knowledge that an agent possesses. Example, a supplier agent may specialize in organic components, while a scheduler agent may specialize in optimizing delivery routes. 2. Communication and protocols. Agents communicate using structured messages and agreed upon protocols to ensure mutual understanding and enable complex interactions. In communication, the act of exchanging messages. This is crucial for sharing data, coordinating actions, and negotiating. In protocol, a set of rules that governs the sequence and format of messages exchanged during an interaction. 3. Orchestration pattern. The orchestration pattern is a method of centralized coordination where a single designated agent acts as a conductor to manage the workflow and dependencies among all other agents. How it works. A dedicated orchestrator agent has a global view of the workflow. It directs the activities of all other service agents, deciding who does what and when. It maintains the state of the overall process. Benefit. It provides simple, predictable control and is easy to debug since the workflow is explicitly defined in one place. Drawback. The orchestrator agent becomes a single point of failure and can be a bottleneck for system performance. 4. Distributed decision making. Distributed decision making is the key characteristic of mass, contrasting with the centralized orchestration pattern. Here, agents make decisions autonomously and locally, using communication and coordination to ensure their actions align with the collective goal. How it works. No single agent dictates all actions. Agents observe their local environment, communicate their intentions or resource needs to relevant neighbors, and make choices based on their own goals and the system's agreed upon social rules. Benefit creates a highly robust, scalable, and adaptable system. If one agent fails, the others can often reroute or adapt without the central orchestrator failing. Coordination. Distributed decision making often uses mechanisms like the shared data space, where agents post decisions or data for others to react to, maintaining coordination without a central controller. The multi agent system architecture outlines the core elements an intelligent agent system needs to function effectively, learn, make decisions, and remain safe and accountable. These components collectively allow the multi-agent system to bridge the gap between abstract AI capabilities and real-world business execution. Essential components of the multi-agent system are discussed here. The first one is memory and knowledge. This component provides the capacity for the agent to remember, learn, and maintain context over time, enabling intelligent, informed decisions. Let's look at some examples. Short-term context. This refers to the agent's immediate working memory. This holds the current conversation thread, recent observations, and transient data necessary for the ongoing task. It's like the agent's scratchpad. Long-term knowledge storage. This is the agent's persistent memory bank containing vast amounts of data, past experiences, rules, and external knowledge bases. This knowledge allows the agent to draw upon historical data or established facts when planning and acting. The second one is tools and capabilities. These are the external interfaces and execution mechanisms that allow the agent to perform actions, interact with the digital world, and process data. Let's look at few examples. Code runners. It enables the agent to execute code to perform complex calculations, data transformations, or interact with APIs directly. Customer relationship management systems. It provides access to customer data, allowing agents to personalize interactions and execute customer service tasks. Monitoring dashboards. It allows the agent to gather real-time data and metrics from the system or environment it operates in, which is crucial for dynamic decision making and performance tracking. The third is policies and objectives. This defines the rules, constraints, and success criteria that guide the agent's behavior and alignment with organizational goals. The examples are compliance enforcement. It ensures the agent's actions adhere to legal, regulatory, and ethical standards. Success metrics, it defines the key performance indicators and goals the agent is tasked with achieving. These metrics dictate how the agent measures the effectiveness of its actions. The fourth one is observability and auditing. These components ensure the multi-agent system is transparent, understandable, and traceable, which is vital for building trust and complying with auditing requirements. Examples are logs. It detailed timestamped records of every action, decision, and communication event the agent performs. Metrics. Real-time data points that track performance, resource usage, and success metrics, often fed to the monitoring dashboards. Transparency dashboards, user interfaces that visualize the agent's internal workings, including its reasoning process, current memory state, and decision path, making its actions clear to human supervisors. Now let's talk about real-world applications of AI agents. Here is a detailed elaboration on all three application topics, explaining the mechanisms and implications of agent-based automation in each area. First, let's talk about automated QA and debugging. This application area represents a significant evolution in DevOps, development and operations, moving towards a fully autonomous pipeline where code generation, quality assurance, and error resolution happen seamlessly without human intervention. Let's discuss few use cases for better understanding. Coder agent. This agent operates like an autonomous developer, often receiving high-level instructions. Example, add feature X to the product. It then translates those requirements into specific code, writing functions, modules, and tests. QA agent, quality assurance. Once the code is written, the QA agent automatically takes over. It executes various testing methods, including unit tests, integration tests, and sometimes even complex end-to-end tests. It verifies that the new code meets all specified requirements and performance benchmarks. Debugging agent. If the QA agent identifies a failure or a bug, the debugging agent is activated. It analyzes the error logs and code context to pinpoint the root cause of the issue. It then automatically generates the necessary patch or fix, which is fed back into the codebase. The advantages and benefits are unmatchable. The main advantage is speed and the reliability. Why? Human developers are freed from repetitive testing and simple bug fixing, allowing for their faster release cycles, and a significant reduction in the number of caused software defects that make it to production. The next area of automation is corporate task automation. This addresses the complexity and volume of administrative and managerial tasks within a business, often leveraging a multi-agent system where several agents collaborate to achieve organizational goals. Let's understand what it does and how it helps in real world. Handling key corporate functions. The agents take over routine, rule-based, and highly structured tasks across various departments. Financial reporting, automatically gathering data from different systems, example sales, inventory, payroll, and generating standardized financial reports. Compliance, monitoring processes and ensuring they adhere to internal policies and external regulatory standards, flagging deviations immediately. Scheduling and logistics, optimizing meeting schedules, resource allocation, and complex supply chain logistics. Customer support, utilizing agents for first-line support, routing complex issues to human experts, and autonomously resolving common queries. Dynamic task reallocation. This is the critical advantage of en masse. As business priorities change, example, a sudden increase in demand for a product or an unexpected regulatory change, the autonomous teams can dynamically reassess their priorities and reallocate agents and resources to the most critical tasks, ensuring the organization remains agile and responsive. The third in the slide is cloud and cybersecurity. This application focuses on maintaining the performance, resilience, and security of modern, often distributed IT infrastructure. Let's discuss few use cases here. Cloud resource orchestration. In a complex cloud environment, agents manage resources in real time. They automatically handle tasks like auto-scaling, adding or removing server capacity based on demand, load balancing, and optimizing costs by moving workloads to the most efficient compute resources. They act as autonomous system administrators. Real-time threat detection. Cybersecurity agents continuously monitor network traffic, system logs, and user behavior. They use advanced machine learning models to detect anomalies that may indicate a security breach far faster than human analysis. Coordinated defense responses. When a threat is detected, the agents don't just alert a human, they initiate an automated defense strategy. In a distributed system, example, servers across multiple data centers or clouds, these agents coordinate instantly too. Isolate the compromised machine or network segment. Block malicious IP addresses. Patch known vulnerabilities across the entire system simultaneously, minimizing the window for a successful attack. The slide highlights how AI agents are being deployed to improve quality, efficiency, compliance, and personalization across diverse global industries. Let's deep dive the domains they have put the footprint as on today, and let me give some examples. In healthcare, agents in healthcare are focused on enhancing patient care quality and operational efficiency through simultaneous, multifaceted actions. Let's look at some examples. Patient data analysis. Agents analyze vast amounts of patient data, e.g., medical records, test results, vital signs, to derive insights, often helping with diagnosis or risk assessment. Treatment scheduling. They automate the complex task of scheduling treatments, surgeries, and appointments, optimizing resources like operating rooms and specialist availability. Compliance monitoring. Agents continuously monitor procedures and records to ensure strict adherence to clinical guidelines, legal regulations like HIPAA, and internal protocols. Goal: improving care quality and efficiency across the board. Let's take an example in banking and finance. In this highly regulated and data intensive sector, agents are used to manage risk, compliance, and customer interactions simultaneously. Fraud detection. Agents continuously monitor financial transactions in real time to detect anomalous patterns and flag or block suspicious activity instantly, minimizing financial loss. Regulatory reporting. They automatically gather data and generate the complex, time sensitive reports required by financial regulators, ensuring timely submission and accuracy. Customer service. Agents handle routine customer inquiries, account management, and information dissemination, providing quick and consistent service. Goal: ensuring compliance and speed in all operations. Let's see how it helps manufacturing. Agents optimize the physical and logistical aspects of production, focusing on reducing waste, minimizing interruptions, and lowering costs. Supply chain optimization. Agents analyze supplier performance, inventory levels, and demand forecasts to ensure raw materials are available precisely when needed, preventing bottlenecks. Predictive maintenance needs. They monitor the performance and sensor data from machinery and production lines. By predicting when a machine is likely to fail, they enable maintenance to be scheduled proactively before a breakdown occurs. Logistics coordination. Agents coordinate the movement of goods within the factory, warehousing, and final distribution. Goal: reducing downtime and costs by improving operational foresight and efficiency, and also in education. In education, agents are used to scale individualized learning and lighten administrative load. Personalized learning paths. Agents analyze a student's performance, strengths, and weaknesses to tailor the curriculum, suggesting customized materials, exercises, and pace of study. Automate grading. They can grade assignments, quizzes, and even essays based on predefined criteria, freeing up educators' time. Support research. Agents can assist researchers by quickly analyzing large databases of academic literature, identifying connections, and summarizing relevant findings. Goal: scaling individualized education to provide a personalized experience to a larger number of students. This slide illustrates a three-stage progression showing how the adoption of AI agents is fundamentally reshaping human roles and workflows. 1. Routine tasks automated. The starting point is the automation of repetitive, low-value work. Agent role is repetitive work is handled by agents, freeing up human employees from mundane, time consuming tasks. This increases efficiency and reduces human error in consistent rule-based processes. 2. Decision making augmented. As agents handle routine work, their next impact is assisting human decision makers. Agent role is the AI powered insights enhanced judgment. Agents process vast amounts of data far faster than humans, identifying patterns, risks, and opportunities. They don't make the final decision, but they provide sophisticated analysis and recommendations, thereby augmenting human cognitive abilities. 3. Team supervise ecosystems. The final stage represents the ultimate change in the human role, moving from task execution to high level strategic oversight. Agent role here is the humans orchestrate agent networks, ecosystems. Instead of managing individual tasks, teams are responsible for designing, deploying, monitoring, and refining the entire network of autonomous agents, becoming supervisors and strategists of an automated workforce. The ethical and practical knowledge needed to set and enforce rules, standards, and compliance frameworks for agent operation. Cross-functional collaboration, working effectively with diverse teams, example, data scientists, ethicists, business leaders, to integrate multi-agent systems successfully. Time for us to talk about how the multi-agent system works for organizations. Businesses must transition from managing human teams to managing sophisticated digital workforces. This readiness involves defining clear operational standards and controls. Organizations must define agent roles and responsibilities, clearly setting the scope, tasks, and expertise for each agent type to prevent redundancy and ensure efficiency. Communication protocols, establishing standardized rules for how agents interact with each other and with human supervisors. Governance guardrails, implementing automated policy controls and risk assessments to manage the risk, compliance, and security of the agent ecosystem. Success metrics, defining measurable outcomes, example, response times, decision accuracy, system throughput, to evaluate agent performance against business objectives. Let's discuss how the multi-layered system works for society in future. As autonomous agents gain power, society must establish frameworks to ensure these systems are safe, ethical, and aligned with human values. This requires addressing ethics and transparency, encoding human values and moral principles into the mass decision making process, and ensuring their actions are interpretable, explainable. Accountability frameworks, establishing clear lines of responsibility for agent actions, especially in case of errors or unintended consequences. Auditability standards, creating methods to track and review agent activity in detail for compliance, security, and performance. So, as we wrap up this deep dive into multi-agent systems, the takeaway is clear. Multi-agent system isn't just a technological upgrade, it's a fundamental redesign of work itself. We've seen how these autonomous AI agents are moving beyond simple automation to become true digital teams writing code, predicting machine failure, stopping fraud, and even personalizing education. In the office, the impact is a three-part evolution. Routine tasks disappear, our decisions are amplified by AI insights, and human teams shift their focus entirely to supervising and orchestrating vast intelligent agent ecosystems. This isn't about replacing people, it's about shifting us from executors to architects. The age of autonomy is here, and the industries changing now from healthcare to finance are just the beginning. The future isn't about if you'll work with mass, but how well you'll design and govern them. If you found this breakdown valuable, hit that like button, subscribe for more deep dives into the future of work, and let me know in the comments. Which industry do you think multi-agent system will transform the most over the next 5 years? We'll see you in the next video.